This video, I'm going to share with you something about the Fibonacci sequence seen from a base 12 perspective that nobody's ever seen before, and I only just discovered it a few hours ago. So this is building on another discovery that I made in using Dozanal Math. Put on my Dozanal Math hat here. I do have a website called dozanalmath.com. You can go there and find out more information about base 12 math. But this discovery that I made has to do with adding the numbers on either side of the length of 1. So you'll notice here I've got these decimal places going on, and what I did is I just changed the sequence of Fibonacci into a decimal place, and I'm using exactly the same numbers as the base 10 version. So here's the base 10 Fibonacci right there. So this is what it looks like in base 12. Then I made that a decimal place, and then the 12th iteration of the pattern gives us the length of 1. If there was no decimals, it would look like 100, but it's in base 12, so that's 12, 12, so it's 144. So my previous discovery with regard to the Fibonacci sequence was that this whole pattern from 0, 0, 0, 1, 1, 2, 3, 5, all the way down to this 0 again. The next number in the sequence is going to be 0, 1, and that whole pattern repeats itself every 24 numbers, every 24 iterations of that pattern. But what I discovered just recently is this. On either side of the length of 1, you notice as we travel outwards, these two numbers are the same. Then the next two numbers, you can add them together. Then these two numbers are the same. Let's just make sure I do this right. And then these two ones, when you add them, you can add them together. And that pattern continues. And when you add them together, you get the length of 1 again. So 0.47 and 0.75 added together gives you the length of 1. 9, again, sort of dec L do is basically 12. You get again the length of 1. They all add up to the length of 1. So I can just keep writing that here. 1, 1, 1, 1, 1. And then these pairs of numbers, if you just add every second number, basically, it's this pattern right here. And that also adds up to the length of 1. So again, this is just the decimal versions, those two numbers. You can kind of see here, you got this, L4, L9, LL, and then it goes, it's going down 5, 3, 1. So that's how that works. So that's something I just discovered. I thought it was interesting because the question I'm asking now is what does that pattern look like? People talk about sunflowers, and the pattern of the seeds inside of a sunflower head is the Fibonacci sequence. So what extra element of geometry is in this pattern where you have this length of 1 kind of balanced back and forth around this in this